Hi everybody, welcome to Econometrics Lecture 5, in which we are going through instrumental variable regression. Remember when you have this simple regression model with a y variable, an intercept, and a slope plus the error term, right? And remember that sometimes we have a biased slope. And this biased slope can come about because there is a correlation between the error term and the dependent or independent variable. And some of the causes behind this can be omitted variables, in which we get omitted variable bias, and another cause of this can be a measurement error in measuring the independent variable, and the last reason can be a simultaneous causality in which X affects Y, but at the same time, Y affects X. So if you have an omitted variable, which is correlated with your present X variable, and it has an effect on the Y variable, then you get the omitted variable biased. But what you can do to get rid of this bias is to include the omitted variable in the regression. But sometimes, or oftentimes, you don't have that data. And sometimes it's actually impossible to get that data. And the second thing you can do is to use panel data. So last week we saw that if you have a lot of entities, right? So this is entities. And you have a time. So you have time here. Then you can actually account for unobserved variables, which are either constant over time for each entity, so it affects the intercept of the entity or the regression, or it's constant across time, across entities, but differs across time, right? So you get this change in the intercept of your estimates for specific entities and time combinations. But this is only possible if this effect is actually constant over entities or time. To get a better view of what we are dealing with, we can look at this diagram to show cases where the OLS yields consistent or inconsistent estimates of the causal effect. So the arrows here, they are telling us where the causality goes. So for example, here the X variable has a causal effect on the Y variable, and the error term, remember that the error term, it just contains all the other variables which have an effect on Y. So, to get consistent estimates, there will be no correlation between the error term and the X variables. This error term, it contains all the variables which are not in the model, so there is no correlation between the left out variables and the included variables in the model. And here we get some inconsistent estimates because there is a correlation here which is different from 0 between the error term and the included x variables. And this is due to omitted variables, or it could be measurement errors. Let's write this correctly. Errors. So, and this correlation between the x variable and the residual can also come about because there is this duality here, this causality from x to y and a causality from y to x. So if you change x, then you change y, but if you change y, you at the same time change x. And this will induce a non-zero correlation between the x variable and the error term. So if we have correlation between the x and the error term, then we get a biased beta, the biased slope. But even if we have correlation between the x and u, then we can use something called instrumental variables regression, and we would get hopefully an unbiased beta. So this, remember that this beta, it's the causal effect of x on the y variable. So even if the correlation here comes about because of measurement error or simultaneity, or there is a missing variable or omitted variable, then we can use the instrumental variables regression to actually get close to the unbiased causal effect. Instrumental variable regression works in the following way. It splits the x variable into one part which is not correlated with the u error term, and one part which we can call v, which is correlated with u, and this is the x hat. It's not correlated with u. And to do this, we need the instrument, and the instrument is just a variable. So, and by doing this, we can use the part which is not correlated with u and use this in our regression, our following analysis, and get a unbiased estimate of the causal effect of x on y.